Hello everyone. In this video, I'm going to go through the basics of object-oriented programming in Java. I'm going to use the IntelliJ IDEA IDE in order to do this. So I'm going to create a new project. I'll call this project OOP Fun. In this project, I'm going to go through an example of modeling a real-life object, a very simple book. We'll go through how to set up constructors, how to set up getters and setters, how to override methods inherited from the object class, and how to test this object book in a BookTester class as well. So let's start with the BookTester class. So the purpose of a tester class or a driver class is essentially to exercise some features of your code, right? So I'm going to define a book class here shortly, and the purpose of the BookTester class is going to be to exercise the features and functionality of the book class. That's why it's called BookTester. So BookTester is going to contain a main, and it's this main that I'm going to run that's going to exercise my book class. All right, so here's my main. Before I can exercise the book class, I've got to define the book class. So that's next. All right, the book class is not going to have a main because this class is going to be used to make book objects. Those objects will be made in another class, like BookTester, that has a main. So first things first, let's go through just a reminder of the basics of object-oriented programming. There are some definitions that I'd like to put in here. They might be similar to ones you've heard before. They might be a little bit different, or maybe you've never done object-oriented programming before, in which case this is going to be a very, very quick crash course on OOP. All right, so first off, let's go through what is a class. A class is a collection of state and behavior that completely describe something. So in this example today, we're going to go through and describe a book. That's the entity that we're going to describe the state and behavior of in this class. There are two things to unpack in this definition. The first is state and the second is behavior. So state is like your member data. In Java, we call these fields or attributes. Secondly, behavior. In Java, these are methods. Really, the behavior represents actions or operations on our state, on our fields. So that's a class. It's like a definition. An object is an instance of the class. The way I like to think about this, kind of a one-line analogy, is a class is like a blueprint, and an object is a realization of that blueprint. So think about the blueprint for a house, right? You might have some architectural drawings. Well, those drawings are not a house, right? They're a definition for a house. But until an instance of those drawings is made, meaning until a house is built, we don't actually have a house. We might use those drawings to build multiple houses. They might all have the same state and behavior, but they might be slightly different in perhaps the colors of the home or perhaps some of the appliances in the home. But they're still all based on the same definition, the same blueprint, the same drawings. So that's my one-liner I like to give in order to kind of pull together class and object in a nice metaphor. All right, next, there can be members of a class. We've already talked about fields and methods, but there are some other members that a class can have. So I'll write these down. Fields, methods, also constructors. This is how we create objects. And a few other ones, nested classes, blocks, etc. All right, so that's enough notes for now. Let's dive into the state of our book class. For simplicity, I'm going to have 3 fields in book. They're all going to be private. So first I'm going to have a string to represent the title, then I'm going to have a string to represent the author, then I'm going to have an int to represent the number of pages in the book. I made these all private. This is the access modifier because it's best practice to put your members of your class to be private until you have a really good reason to go with a different access modifier. Essentially, this is like encapsulation. So we want to keep things private to their types unless we have a reason to expose them. Later, we'll come back and add some getters and setters, and that's how we'll allow outside access to our private fields. All right, next, constructors. Something that's kind of nice about Java is we get a default value constructor for free. And I call a default value constructor a DVC. So if you see me type DVC, that's what I'm referring to, a default value constructor. So for free, I mean we don't have to explicitly right now write code for a constructor. We get one for free. So we can start making book objects. I'm going to head over to BookTester and make our first book. So we'll start with the type of our object reference, type book, then the name of our reference, I'll call it book 1. We'll use the new keyword in order to invoke a constructor for our book type. This is a default value constructor, so I'm not going to be passing in any arguments. If I print out book 1, we're going to see some strange output. Here's what we get. Perhaps you've seen this output before. So this output comes from capital O objects toString. So I'm going to take a little bit of notes about object and toString back in the book class. So every class in Java either directly or indirectly inherits from object. And note, this is capital O object. Sometimes I say that out loud to be really clear. So this is actually a class defined in Java that we are provided access to. So up here when I define book, I didn't say something like extends object. This is how we define inheritance in Java. But even if I didn't write this, it's implied, it's implicit. Book inherits from capital O object. This is kind of important because we're going to inherit some essentially default functionality from object. So one of the default pieces of functionality we inherit is something called a toString. After we finish our constructors, we're going to actually override toString so that we can provide output that's a little more descriptive of a book than the default output or default string representation of any old object in Java. All right, so let's finish our constructors first. Next, let's do an EVC, an explicit value constructor. So with an EVC, we're going to be actually passing in arguments to our constructor that will store in parameters and use to initialize our fields. So we're going to have the access modifier for our EVC be public because we want this to be accessible outside of the book class. Like, for example, so BookTester can make book objects using our EVC. So now I'm going to have 3 parameters, one to store an incoming value for each of my 3 fields. I'm going to name all of these parameters with the word param in front, and I will explain very soon why I'm doing this. All right, so now I just need to go and set each of my fields to each of these values. So title is going to be assigned the value in param title, author, param author, and so on and so forth. Before I go and run this, I want to explain why I put param in front of each of my parameter names here. So right now you can see that title, author, and num pages are kind of showing up in bold. Okay, these are being recognized as fields by the IDE. Now I have a title named field, and if I had a parameter also named title, then I'm going to have a little bit of trouble here. So first off, notice that title is no longer purplish pink bold, it's gray. So recall a little bit about scope. So scope always resolves to the more local name. Recall that a parameter is really just a local variable. So if I have a parameter that's a local variable called title, then whenever I use title, in the scope of this block, it's going to refer to the local variable, not to the field, which has larger scope. So essentially what's happening here is something called shadowing. The parameter title is shadowing the field title. This is okay. We can have a local variable that's the same name as one of our fields. What we have to do is make use of a special keyword in Java called this. So I'm going to type this dot in front of title on the left-hand side of my assignment operator in order to be really explicit and say I'm referring to the title of this object. Notice how title became purplish pink and bold again? Now the IntelliJ IDE is recognizing that this is in fact referring to the field title, not to the parameter title. I'm going to make a little blurb about this, but I'm going to return to the idea of this here shortly. So this refers to the invoking object. Right now we're in a constructor, so we don't have an object that we've used in order to invoke a method, for example. So in a constructor, just to be more clear, this refers to the object being created. So note that our constructor here isn't static, which means it's instance level. This refers to that instance. Okay, remember back to our analogy of blueprints and houses? So this refers to the current object, the current house, okay, inside the definition of a house. It's essentially what we're doing here. It really helps to draw pictures of objects and references. Hopefully you've done that before. It's difficult for me to do here in IntelliJ, but I'm going to talk more about this here shortly. All right, this is great. I'm going to save this. I'm going to head back over to BookTester, and we're actually going to find that we've broken our code. If I try and run this now, I'm actually going to get an error. Okay, so it says Java constructor book and class book cannot be applied to the given types. So it's saying I need a string int, but I'm getting nothing. So I'm going to head back to book and make a note about this. Once we define a constructor, it doesn't matter if it's an EVC or a DVC, we lose the free DVC. Okay, so remember up here I said we get a default value constructor for free and I was all excited. Well, since we defined our own constructor, we lose that free one that we were given by default. So we can fix this really quick. Let's just define our own DVC. So this constructor is not going to accept any arguments, so it has no parameters, and it's going to set to each of my 3 fields just some default value. I'm just kind of making these up, doesn't really matter. Note that optionally, I could also use this dot on each of these field references in order to fully qualify the name and be explicit. But since there's no shadowing here, that's totally optional. In fact, This is mostly up to programmer preference. Some programmers like to use this to be explicit whenever possible, and some prefer to only use it when they have to, like in the case of here of shadowing. All right, let's see if we can run this now. Perfect. Now let's exercise our EVC. So first I'm going to pass in a string for the title, and I'll do Harry Potter 1, then a string for the author, J.K. Rowling, and an int for the number of pages, which I really don't know, so I'm going to make this up to be 275. Note that title, param author, and param num pages, these are just labels provided by the IDE. This is not part of my source code. Don't type those. I didn't type them. This is just a feature of IntelliJ. And it's kind of nice, right? All right, so that's a quick crash course in constructors. Now let's talk about overriding toString so that we can get some more accurate or more representative strings to represent our objects. So we're back in book. Now let's override toString to provide a better string representation of a book. Something like Harry Potter 1 by J.K. Rowling would be much more descriptive and better for debugging purposes than book at this hash code or this data here. Before we do this, I want to have a little aside on annotations. So annotations are metadata or meta information about your code that's used by the compiler and the IDE, and some documentation tools as well. So they start with an @ sign. You might have seen something that looks like @deprecated, or one we're going to use right now, which is @override, or another common one is @suppress warnings. If you've used JavaDoc before, you've seen annotations in action before, like something like @author or @date. These are common annotations used in JavaDoc. Spell that right. Okay. So these are not going to affect the execution of your program in any way. They're optional, but they can help the compiler optimize your code, or they can help the IDE provide features while you're editing your code. And they're in general just good practice to include. So because I'm going to override toString, I'm going to have an @override, and then my definition to override the default functionality, the inherited functionality of toString from the object class. So this method header that I'm about to type has to match exactly the toString method header in the parent class object. So it's public, it returns a string, and it's called toString, and it doesn't accept any arguments. And all it does is return a string representation of this object. So mine's going to be pretty simple. I'm going to return the title of the current book, this book, by, and the author. So whenever a string representation of an object is needed, this toString method is going to be invoked or called implicitly. So I don't even have to change anything in BookTester. If I run this now, I'm going to see my title and my author separated by the word by from my toString here. This is a great opportunity to return to the idea of this. So this refers to the invoking object or the current object. So for example, in main, suppose I did something like book2.toString. Okay, I don't even need the toString there if I'm trying to use println for book2, because println needs a string, so toString will be called implicitly. But I'm going to be very explicit here. Let's say I'm calling book2.toString. So in this case, book2 refers to the invoking object. In this toString method, this would also refer to the same object as book2, effectively making this an alias for book2. Let's say we were in main and we were to call book1.string. Then in the context of toString, this execution, this would refer to book1. This always refers to whatever the invoking object is. And the invoking object is the reference to the object in front of the dot before the method call. Okay? Note that this type of syntax is specifically for instance level methods, where we have a reference to an object, dot, and the name of a non-static, an instance level method. And I'll make one little note here. Instance level, non-static. If you were in a static method, that would be class level, and there would not be a reference to this because there would be no invoking object. It's kind of heavy stuff, but it's really important to understand the difference between static and non-static. All right. Our last big topic, getters and setters. So recall our 4 access modifiers, right? We have public, accessible anywhere. We have package private, accessible only within the package. We have protected, which is the same as package private, plus accessible from any subclass, even if that subclass is in a different package. That requires some knowledge of inheritance. And then the last one is private, and that's what we used up here for our fields. So if I head over to BookTester, we'll see private in action. Private means only accessible from that class. So since we have 3 private fields in book, those fields are only accessible within the book class. If I tried to do something like book2.title, I'm going to get an error. Book2 refers to a book object that has a private member title. Since I'm in BookTester and not in book, I can't see title. So what we can do instead is expose functionality as needed via getters and setters for our fields. I'll say expose state and behavior, or more generally, expose members of a class as needed. So let's start with a getter. A getter is also known as accessor. It's used to access data. So I'm going to make this getter public so that I can access it from anywhere outside of this class. I could also use package private, which is omitting a modifier, or I could use protected, but I'll use public because why not? All right, so public string get title. And all I'm going to do here is return title or this.title. Since this is public, I'm going to head over to BookTester, and now I'm going to be able to see get title and be able to access the title field through a controlled method or through a controlled entry with get title. All right, next is setter. And a setter is also known as a mutator because it mutates and it updates our data. So this return type is going to be void, but we are going to accept an argument and store that argument in a parameter, perhaps called new title, or I could even do title if I wanted to do shadowing again. All right, so I could head over to BookTester. Let's do this real quick. Let's do book1.setTitle, and let's just do something like a new title. Just doing a little test here. And then I'll print out book1, and we are going to see an updated title right here for book 1. Before it was capital blank title, but now it's lowercase a new title. All right. So back in book, I now have a getter and setter for one of my 3 fields. I'm going to also add a getter and setter for my 2 other fields, but I'm going to do this a little more quickly. A lot of this code I'm writing in here is boilerplate code. It's code that has to be here, but it's not very specific to my application or context. It's fairly default behavior that just takes time to code up. Like, for example, these getters and setters, there's nothing unique about these that I'm implementing. They're just boilerplate code. So I'm going to show you a cool little shortcut that you can use to generate some code in your project. So it's called generate code to let IntelliJ write some code for you. So if you're on Windows, to bring up the generate code menu, it's going to be Alt Insert. And if you're on a Mac, this is going to be Command N. And this Windows keyboard shortcut should also work for Linux. So if I do Command N, you can see it's going to bring up the generate code context menu. And I can click on any of these things to have it generate some code for me. So I want a getter and a setter. And it's saying, okay, well, you want a getter and setter for which of your fields that you don't already have a getter and setter for? Well, I want author and pages. Press enter, and there are my 4 getter and setters that I would have written. They would have looked just like this, the ones I wrote. So that's really nice. Another keyboard shortcut is the override methods menu. And it doesn't matter what OS you're on. This is Control O. And this is nice, maybe not so much for our little book example here, but this is nice when you're, say, subclassing a class that's got, kind of an extensive ancestry. It has a lot of inheritance to it, or maybe it implements quite a few different interfaces. This could be nice because it's going to show you all of the available methods that you can override. So we've already overridden toString, but if I were to delete toString, it would show up here. So here are the 4 other methods that we inherit from java.lang.object. Remember, object is the superclass, either directly or indirectly, of every class in Java. So there's 5 methods that we inherit: hashcode, equals, clone, finalize, and toString. So I'm not going to implement any of these. I'll just close that out. But I did want to show you these 2 keyboard shortcuts because they can greatly help you. I want to emphasize that if you're new to Java, I definitely encourage you to type out all of your fields and your constructors and your override methods and your getters and setters. It's really good practice, and you still need to learn the details of the Java syntax. Don't let IntelliJ write too much code for you. You want to make sure that you understand everything, and then you switch over to using generate code to save you some time. All right, I'll close out this video with a little call to action. So here's a task for you to now open a new project, or you can even continue working in this one and code up a class all on your own. So here's the task. Create a point class and a BookTester class. So the point class represents a point in 2D space. So it should only have 2 fields, an X and a Y. And the toString for a point should be something like, let's say X is 0 and Y is 0, paren 0, X, comma, 0, Y, paren. Kind of this nice Cartesian coordinate pair you might have seen before. You should also have some getters and setters, and BookTester should test your point. After you create a point class, you could also create a circle class and a circle tester class. So circle has a center, which is going to be a point, and it has a radius, which is going to be a double. It's okay to have multiple tester classes in one project. Each one will have its own main. You'll just have to create a run configuration for each main in order to run it. But it's totally fine if you want to create point tester, circle, and circle tester all in the same OOP Fun project that you started for this project or for this video. Make one more note and then I'm done. So here I said circle has a center. Okay, and it's a point. Circle has a point. Whenever you hear a has a relationship like you've seen here or heard here, this implies a composition, which is a notion in object-oriented programming where one type composes another type. Okay, so circle has a point. Circle is composed of a point. We don't necessarily say that circle has double, because double is a primitive. This is typically just for our OOP, our classes. You've already seen composition before. For example, in book, we have toStrings, and string is a class. So this is composition here because I have a class book that is composed of another class, string. This is in comparison to something called an is-a relationship, which implies inheritance. For example, book is an object. That's an example of inheritance. Book is an object, not book has an object. Book has a string, not book is a string. All right, so in another video, I'll talk about inheritance and go through some examples, but really work through the circle and the point classes. This is a great example of composition where both classes are programmer defined, whereas here only our composing class, book, was programmer defined, and it was being composed of string, which is provided by Java. So that's it for the video. Hopefully you learned a lot, just a crash course or review in object-oriented programming in Java. We've really only scratched the surface. Some things to look into after this: inheritance for sure, interfaces, polymorphism, encapsulation, and abstraction. Those are some great topics for further learning with OOP and Java. Thanks for watching the video. Hope you enjoyed it.